thing. Okay, number 8. This is the hardest one in the homework. Here we go. You know, step 1 is to graph at desmos.com, get any clear zeros. Okay, I've got the graph for us here, and you can see some clear zeros. Actually, there's a couple of them, huh? So this is 1, 2, 3, 4, 5. So right there at 3. And then right here, this one's at -1, isn't it? So we have 2 clear zeros on the graph. X equals -1 and x equals 3. Okay, x equals -1. Here, let me put it over here. X equals -1, x equals 3. And then notice what they say. They say 6i is a 0. So that means x equals 6i is a 0. And here's a special rule that you need to know about. Imaginary, which are also called complex. An imaginary number, a complex number, an imaginary number, that's a complex number has an imaginary and a real part to it. So this is really 0 plus 6i. Its real part is just 0. Its imaginary part is 6. That's a complex number. Complex meaning it's not simple. It's made out of 2 things, a real number 0 and an imaginary number 6i. So a complex number or imaginary, it's pretty much the same thing. Imaginary complex 0, if you have one like we have one right there, always the conjugate is also a 0. Now, what do I mean by conjugate? Opposite sign on the imaginary, in the middle on the imaginary part. Opposite sign, sorry, I'm getting a little scribbly there. Opposite sign, let's say, opposite sign in the middle on the imaginary part. So if we have 0 plus 6i, that's really how you would write out. I mean, you don't really need the 0. Then the conjugate, that's the one we have right here, 6i, which is the same as 0 plus 6i. The conjugate, which means, conjugate always means opposite side in the middle. When we do that in math, we use that for various things. Conjugate means opposite side in the middle. That'd be 0 minus 6i. You just change the sign in the middle. In other words, you change the sign on the imaginary part. So in other words, it's really just minus 6i. The 0 is not doing anything. That's also got to be a 0 automatically. That's what we're saying. Whenever you have an imaginary 0, its conjugate will also be a 0. So if 6i is one of our zeros, which they told us it is, then minus 6i, the conjugate, the opposite sign in the middle on the imaginary part, is also a 0. So we really know that x is minus 6i is a 0, as well as x equals regular 6i, and x equals -1 and +3. We can see those from the graph. So we already have 4 of the zeros. And this is 5th degree, so there's only one more to go. The degree tells you how many zeros, right? There's only one more to go. So we just need to find that last one, but that's easier said than done. So I'm going to go to a fresh screen where we have a little room to work, taking the information we have. So now on number 8, we have the function p of x equals